Hello everyone. It's a great pleasure meeting you all in my mathematics class. Today let me continue with finding the derivative of functions. But today I have taken a different type where the variables are given in terms of parameters and then we are asked to prove certain results. See, here you are given x is equal to sine t and y is equal to sine of pt. That means x is a function of t and y is also a function of t. And we have to prove the result cos t into y1. y1 is nothing but your dy by dx. What is your y1? y1 is equal to dy by dx. And if I write y2, it means it is d squared y by dx squared. So this is the understanding that you must have. So this is cos t, that is these two are given, we have to prove this result. See, what is that we want here? You just see the result here, it is y1. y1 is dy by dx. So let me find out what is my dy by dx. y1 is nothing but my dy by dx. But this y is a function of t, so it has to be differentiated with respect to t in order to, before getting this dy by dx. So dy by dt divided by dx by dt. After all, this is dy by dx. You see that dt and dt will go for you dy by dx. At the same time, this for y is differentiated with respect to t and x is also differentiated with respect to t because they are functions of t. Now what is dy by dt? dy by dt is nothing but what? The immediate differentiation is cos of pt. Sine of pt is cos of pt. And the differentiation of pt is p. P into differentiation of t is 1. Therefore it is p of cos pt, and the differentiation of sin t is cos t. Therefore you will get y1 is equal to p cos pt divided by cos t. Cross multiply, what is it you will get? When you cross multiply, y1 into cos t is equal to p cos t, and this is proved. One proved. One is proved. Now let me go to this step. What I do here is that I find out the value, of this, I find out the value of this, I find out the value of this, and do this minus this x into y1, that is y minus x squared into y2 I find, then x into y1 I find, then p squared y I find, and do as given in 2 and see whether it is equal to 0. Now, what is my y2? y2 is nothing but d squared y by dx squared. But this d squared y by dx squared is nothing but d by dx of dy by dx. I write this, know this dy by dx is given is in terms of t. And therefore you see that this got to be different, can be differentiated with respect to t. Therefore I write this as d by dt into dy by dx into dt by dx. See, dt and dt go off giving you what? D by dx of dy by dx. So I write this as d by dt of dy by dx into dt by dx. And you must know that this dy by dx is a function of t only here. Okay. So d by dt, see I write it here, d by dt. What is dy by dx? P cos pt divided by cos pt. See, p cos pt divided by, so I will call it as using something like this. I don't want to write more on this, so I will just follow me, you will understand. So this d by dt of this dy by dx is nothing but what? P cos pt divided by cos t into, what is this dt by dx? See here, if you take this is nothing but dx by dt is cos t. Therefore dt by dx will be 1 by cos t. See, dt by dx will be 1 by cos t. Therefore I write it as what? It is 1 by cos t. Now if you go for now, after then you have to use the quotient rule to differentiate this. Cos t into p is a constant. Therefore differentiate cos of pt. So when you differentiate with respect to t, it is minus p sin pt. But already when p is there, therefore you get it as minus p square sin pt minus p cos pt into differentiation of cos t is minus sin t. Minus into minus will make it as plus. So you get it as cos t into minus p square sin pt plus p sin t cos pt divided by v square. V into du minus v du minus u dv divided by v square. That is the quotient rule. So I apply the quotient rule, therefore this becomes cos square t. Outside 1 by cos t is there. So when you multiply, you get this as p sin t cos pt minus p square cos t sin pt divided by cos cube t. Therefore, now I want 1 minus x squared into y2. Now what is my 1 minus x squared? X squared will be sin square t. So it will be 1 minus sin square t. This is 1 minus sin square t, which is equal to cos square t. So you see that in this place 1 minus it is sin square t, so it is cos square t. Therefore cos square t into y2 will be equal to multiply throughout by my cos square t. So cos square t and 1 cos square t will go off, giving you what? Cos t. So you are left with this. So on simplification you get it as p sin t cos pt minus p square cos t sin pt divided by cos t. You call it as result 1. Result A, small a. Then I will find out what is my x into y1. See, already I know what is my y1. See, here you have got this y1. What is the y1? P cos pt divided by x. So multiply this by x into y1. So x into y1. What is your x here? Sin t. So sin t into p cos pt divided by cos t, that is equal to p into sin t cos pt divided by cos t. Call it as result B. Then I want my p square y. What is p square y? P square into what is your y here? Sin pt. So p square sin pt. So I have got this. A I have found. This is my A. This is my B. And this is my C. Now I am writing it as A minus B plus C. You will find that here this is C. Here you have got here the denominator cos t. The denominator cos t. But here there is no cos t. So the LCM will be cos t. So throughout multiply it by what? So when you multiply with this cos t, here you will get this one minus this one minus p square sin pt into cos t. Now you will find that when you substitute, when you do the simplification, you will find that p sin t cos pt. You can find that p sin t cos pt and this will go. This is p square cos t sin pt. This is minus and this is plus. So p square cos t sin pt. So these two will go off, giving you 0. So this is 0. 0 divided by cos t is 0. So you have got this result. So to prove. So this is all about this problem. So you have to you must know that the parametric representation of the variables are given. Then we have to go for the differentiation like dy by dx or d squared y by dx squared second derivative. In this way, how I have explained in this problem. Okay. Now let us find the nth derivative of y is equal to e to the power of ax into sine of bx plus c. We have to find the nth derivative of this. You find out what is y1. When you do y1, you should be familiar with the differentiation. So u into differentiate u, that is with respect to x. So e to the power of ax into differentiation of ax is a into sine of bx plus c. Then keep this as a constant, differentiate sine of bx plus c. Immediate differentiation is cos of bx plus c. Into differentiation of bx is what? Differentiation of bx is b. Now here we will get it as b into e to the power of ax into cos of bx plus c. Now as such it will be difficult for you to get the nth derivative. So I do some manipulations here. What I do here is I take this value a as some r cos theta and b as r sin theta. I take the value of a as r cos theta and b as r sin theta. So that my r squared, see when you take square this, what is it you will get? A square plus b square will be equal to r squared into sine square theta plus cos square theta. When you square this, a squared will be r squared cos square theta, b squared will be r squared sine square theta. So r squared into sine square theta plus cos square theta is 1. Therefore, you will get r squared is equal to a squared plus b squared. And you go for this b by a. What is that b by a? It is r sin theta divided by r cos theta. So you will get it as c b by c. It is r cos theta, r sin theta divided by r cos theta is equal to b by a. That these two will go, giving you tan theta is equal to b by a, or theta is equal to tan minus 1 of b by a. So this is what you get. So that is what I have written here. This is what you get. Now substitute the values here. So when you put here, it is e to the power of ax into r cos theta sine of bx plus c. And here it is what? R sin theta. See here it is plus r sin theta into sine of cos of bx plus c. Now you see that this is sine a cos b. Can you see this? So I will write this as you see. This is nothing but take this e to the power of ax outside and r also outside. So you will get sine bx plus theta cos theta bx plus c cos theta, then sine theta sine whatever here sine theta cos bx plus c. So this is in the form sine a cos b. Here in the place of a you have got bx plus c, in the place of b you have got theta. So this is in the form sine a cos b plus cos a sin b, cos a sin b. So that is nothing but what? Sine of a plus b. What is in the place of a? This is your a, this is your a, and this is your b. So this is sine a cos b plus cos a sin. This is cos a sin b. So this is nothing but what? Sine of a plus b. That is bx plus c plus theta. So what is that you have got here? I will write it as like this. So I will put it in this form. So it is r to the power of 1 because you are finding the first derivative. R to the power of 1 e to the power of ax sine of bx plus c plus 1 time of theta. Then you go for the second derivative. So here you see that this is r into differentiate as we have done earlier. The differentiation of this is a into e to the power of ax into r is there into sine of bx plus c plus theta plus r into e to the power of ax. Okay, keep it as it is. That is, you treat it as a constant and do the differentiation for the sine of bx plus c theta. And when you do the differentiation of sine of bx plus c plus theta, it is cos of bx plus c plus theta. And differentiation of bx is b. That is why I have written here. So when you go for the differentiation, it is a into e to the power of ax r into sine of bx plus c plus theta plus b into e to the power of ax r into cos of bx plus c theta. Now you see that here you can see these things can be taken. See here. Here again what I do here is after getting this result, I take again this a x is equal to r cos theta and a is equal to r cos theta and b is equal to r sin theta, so that you will get the same thing. See the same result you get. Again you take a is equal to r cos theta and b is equal to r sin theta. So when you substitute the values here, what will happen is y2 is equal to, in the place of this, r cos theta. See, r cos theta, but already one r is there, therefore r squared into e to the power of x into cos theta into sine of bx plus theta. And here, if you put here r sin theta, it is r into r is r squared into e to the power of x, and it is sin theta into cos of bx plus c. Here you take this now as what? You take this as e, take this as b, take this as a, and this as b. So what is that you will find? So take these things outside. That is, you take this r square e to the power of ax, r square e to the power. Then you write the rest of the things. So when you write the rest of the things, it is sin a cos b plus cos a sin b. It is sin a cos b plus cos a sin b. In the place of a, you have got bx plus theta, and in the place of b, you have got theta. So again, you have to apply sin a cos b plus cos a sin b is sin of a plus b. So here you see that it is r square into e to the power of ax into sin of bx. See, bx plus c plus theta. See, I have to add this theta. So you will get it as what? It is 2 theta. R square e to the power of ax, this is 2 theta. 2 times of theta. So I will write this as y2 is equal to r square, r to the power of 2. Second derivative, so r square e to the power of ax into sin of bx plus c plus 2 theta. Now, so the third one, if I do, it will be y3 will be equal to r cubed. So what is your y3? So your y3 will be what? y3 will be r to the power of 3 e to the power of ax into sin of bx plus c plus 3 theta. And when you go for y4 will be r to the power of 4 e to the power of ax sin of bx plus c plus 4 theta. So this pattern will continue. You substitute, you will get. So when you substitute x is a is equal to r cos theta, a is equal to r sin theta, and do the differentiation and apply the results, you will find that this is the pattern that you will get. So continuing in this process, see if it is y3 third derivative, it is r cube and it is 3 theta. If it is 4, r to the power of 4, 4 theta. If it is 5, it is r to the power of 5, 5 theta. Continuing in this way, proceeding in this as above, and we will get yn means what? R to the power of n into a to the power of x into sin of bx plus c plus it is n theta. So what is it? This is your nth derivative of the function y is equal to e to the power of x into sin of bx plus c. Now, so this is where r is equal to, this is, so what is the value of here r? R is nothing but your a square plus b square whole to the power of half. Therefore, what is your yn? So yn will be equal to a square plus b square whole to the power of n by 2 into e to the power of ax into, you will get it as sin of, see here it is theta, see sin of bx plus c plus n theta. And this theta is nothing but what? Tan minus 1 baby. So if you want, you can just verify. Put n is equal to 1. See, if you put n is equal to 1, you will get the first result. This result you will get. When you put n is equal to 1, see what is your y1? You will get y1 is equal to 1. When you put y2, you will get the second one. Third, likewise you can get. So this is how we find the. Similarly, if you are asked to find, go use a similar method. If you are asked to find the nth derivative of y is equal to e to the power of ax into cos of bx plus c, proceed in the same lines, you will get a result of this type. That is yn will be equal to r to the power of n e to the power of x cos of bx plus c plus n theta. So this is how we do. These two are important from examination point of view. Try to learn.